Hello, everyone. I'm very honored to be here to introduce AtlasGraph, a high-performance graph database solution for complex data challenges. My name is Juan Yang, and I'm from Haizhi Technology. So please let me introduce my company. We have a history of 10 years, and our headquarters is in Beijing, and we have branches in Shenzhen, Shanghai, and Hangzhou. And we have 1,000 employees now, and we focus on big data, data mining, data analysis, and we facilitate the digital transformation across all industries. And in the past few years, we achieved some honors, like in 2021, in partnership with Tsinghua University, we received the CCF Science and Technology Award for Technological Progress Outstanding Achievement. Of course, it's an award about graph computing. And in 2022, we achieved CIE Science and Technology Award, and together with Ant Group, it's also about graph computing. And we are recognized by Gartner as the leading force in data analytics. We were named a representative vendor in the Market Guide for Analytics Platform China, Market Guide for AI Software China, Market Guide for Graph Database Management Systems. So these recognitions underscore AtlasGraph commitment to delivering cutting-edge data analytics solutions that empower business worldwide. And last year, we achieved the LDBC SMB Interactive Benchmark and achieved the highest score ever recorded, but that's for that time. So that's December in last year. We have served leading clients across diverse industries. The major banks in China, like CMB, CCB, ICBC, also the government system, the police, security, emergency office, customs, city transportation center, and so on. And also energy industry, the state grid, and also some other industries. So I think we are among the top big data product and service company in China. And a quick look at the graph database. It's very hot this year, but we can see, although there is a little bit slide down, but it's still the hottest topic in DB engine. And we can see okay, I'm the last one, but I still talk a little bit about this. The relational table is simplified the real word to use the row, the column to describe the word, but it lost the connections, the complicated structure, which is exists in the real world. So that's why we developed graph database. We want to describe the word in a more real way. So multi-context is preserved with graph analytics. I think that's why we are here, all the people in the room and also on the line. We are all believers of graph technologies. So that's the all the background information. And now come to AtlasGraph. The key features of AtlasGraph. Because we, Haizhi is a company serve the enterprises, the governments. So from day one, we know what the big customers, what they need. So we build our product in a cloud-native way, and it's a distributed architecture, and we provide HTAP capabilities and the real-time large-scale graph processing, high performance MPP, easy of use. That's our key features. So it can support the big customers' requirements. And this is our architecture overview. We have several layers: the store server, the meta server, the graph server, and the application layer. We built our product in Rust. Rust is new and secure and fast language. So I believe we are the first Rust-based graph database in China. So we also build distributed architecture for linear scalability, and we optimized our storage and computation for large graphs. And we set up our MVCC mechanism for transactional consistency, multi-replica management for HA, online backups for disaster recovery. So that's our key features: scalability, reliability, and usability. Okay, I will talk a little bit more about how we implement them. We are a labeled property graph model because for the enterprises in the real business world, there are a lot of information about business. So if we have labels, have properties, so there are more information can be stored in the graphs, not just the structure, but also the properties of the humans, the devices, or the accounts, so we can make more complex queries and the computation over the graph. So that's the graph model that we chose. And the query language, we also select Cipher-based because Cipher has a very good 群众基础 or user base in China. So it's a SQL-like and analyst-friendly and very easy to use. We did push-down optimization, breaks down queries for targeted optimization, and pushes computation closer to the data, minimizing data movement, enables parallel processing for optimal resource use and faster results. So that's our push-down optimization, which is tailored for graph workloads. High availability, because for the banks, they care a lot about HA. Their data center are set up in different positions, and they want to, they can be available almost all the time. So we provide data high availability and service high availability. We implement a chain replication for robust data copies, and we separate read and write for better performance. And we built active standby architecture for critical services, and we use Raft consensus for seamless failover. So that's for the high availability part. And also, moreover, we provided cross-region high availability. The data durability, we leverage chain replication for data replication across AZs, ensure data safety and service continuity even in the event of an AZ failure. and the system will automatically recovers from AZ failures without manual intervention. And the data consistency is maintained throughout the failover process. So that's the cross-region high availability. And we implement distributed transactions because the transaction is very hard for the graph because the data structure is very different from the traditional data structure. So we do spend a lot of time in implement these distributed transactions because like CCV, like they all want this. So we implement this MVCC-based transaction management to ensure data consistency without sacrificing analytical performance. Yeah, that's the sequence diagram. We also build multi-tenancy. We can isolate resource with different resource groups. So to isolate tenants while sharing a single database instance. And we have granular control to allocate CPU priority and memory per resource group. So with all this work has done, we can provide predictable performance, efficient resource utilization, and enhance the security. So this is multi-tenancy. And we build powerful graph algorithms to unlock the deeper insights into the data. So we have more than 30 built-in algorithms, including path finding, community detection, similarity calculation, and some advanced algorithms such as loop detection, chain identification, or pairs shortest path, and subgraph pattern recognition. So with all the algorithm, the user can easily invoke algorithm directly within Cipher queries, and they can perform targeted analysis on user-defined subgraphs, and they can also fine-tune algorithm behavior to suit their specific needs. And we also optimize the algorithm for real-world deployments. We have the hybrid execution modes to seamlessly switch between a single machine and distributed computing for optimal performance in diverse environments. And we provide algorithm-specific optimizations. The user can head to implementation for common algorithm to deliver superior performance. And our design is also resource efficient to excel in environments with limited compute resources and network bandwidth, because most of our customers do not have very luxury PC servers to install the products. Most of them have very limited compute resources for this kind of data analysis project. So we refine our product to be very resource efficient so that the customer can use them with low cost. And we unify the real-time and analytical processing. We build a connector to synchronize the data between OLAP and OLTP and OLAP. We have an index manager, snapshot manager, and bin log parser, and a multi-shard log merger. So with all this set of mechanism, we make the OLTP part and OLAP part synchronized and integrated. So that's the HTTP part, and also to cover the scenario which requires super fast computation. So we also build in-memory caching to turbocharge graph queries. Because we know graph computations are often I/O intensive with random and scattered data access patterns, so we built an efficient in-memory cache which significantly accelerate query performance. So with this efficient caching and zero cost retrieval, and it's also very safe and secure. So the customer can load the data into the memory to make a calculation which requires super fast speed. Yeah, that's for in-memory caching part. Okay, and last, because today everybody is talking about the large language model, we also built a graph agent, but our graph agent is work with large language model to improve their accuracy and to reduce the hallucination of large language model. So with this agent, we can extract the relevant documents and build them into a graph. So we can use the rule-based methods to extract knowledge graph, and we can also use the large language model to help build the knowledge graph. And this knowledge graph will be like a knowledge base to support or to help the large language model to give or to produce the precise domain-specific answer to the questions. So we have implemented this graph agent in quite a few of our customers. They are very happy to have it because every big customer is working with large language model, but they find that it's very hot, but there are a lot of problems when turning it into production. But with this graph agent, they can leverage their domain-specific knowledge and to reduce all the mistakes that large language model has created, and to make this scenario really can be put into production and to be delivered to their customers. So that's how we work with our graph agent. Okay, so that's all for my speech. Thank you very much.